Today we are talking about greatest common factor, something you've done many times. And I'm going to show you 3 different ways of doing the first problem, and then I'm pretty much going to pick one of those 3 methods to do the remainder of the examples. So, how were you originally taught to find greatest common factor? Probably like this. You probably said, okay, for the number 20, I know it's 1 times 20, it's 2 times 10, it's 4 times 5. I know all of those statements make 20. And for 30, I know I can do 1 times 30, 2 times 15, 3 times 10. Can't do anything with 4. We can do 5 times 6. So we would write down all of our multiplication facts, and then we'd look at both of these and say, okay, the biggest number that I can find in both is 10. So the GCF is 10. Okay, that's not too bad. If your numbers are relatively small, that won't hurt too much. But as we have more numbers, and as we get larger numbers, this process becomes very painful very quickly. Second option, use factor trees. So with factor trees, there are 2 ways you can go about getting the answer here. The first is to identify anything that is common to both. So like they both have a 2, they both have a 5. That's all they share in common for their final statements. And 2 times 5 makes the 10. Alternatively, still using this list though, and I'm just going to do it to the side here, 20 is 2 to the 2nd power times 5. Let me... 30 is 2 times 3 times 5. So if we look at both of these and say, okay, what's the same in both? As far as the 2's go, they both have 1 2 at least. Yes, 20 has an extra 2, but since it's not shared with 30, we can only take 1 2. They do not both have 3's, so we can't take the 3. They do both have 5's, so we can take the 5. And there's my 2 times 5 is 10. So first option was write out all the multiplication facts, find the biggest number. Second option, do your factor trees and find what's common. Third option, and this is probably new, it's what I call the ladder. Now, in order to use the ladder, which we're going to be using pretty much for the rest of this section, you do need to know your prime numbers to a certain extent. So those are 2, 3, 5, 7, 11, 13, 17, so on, so on, so on. I'm not going to say this is all you will need, but odds are good we won't need to go too crazy. So let me show you how the ladder works. I'm going to ask a simple question. Can both, or all when we get to 3, but can the numbers divide by 2? I'm going to start with the first prime number. 20 and 30, yeah, they're both even. So 2. Write down the fact they can divide by 2, and underneath the numbers, do that division. 20 divided by 2 is 10. 30 divided by 2 is 15. Can both of these numbers divide by 2? No. Can they both divide by 3? No. Can they both divide by 5? Yes. Write down the fact they can divide by 5 on the outside, and then do the division. 10 divided by 5 is 2. 15 divided by 5 is 3. 2 and 3 now will not do anything. There's nothing they share in common. These two numbers on the left will tell me my GCF. 2 times 5 is 10. I'm going to be using the ladder from here on out. Primarily because using this ladder will also let me find least common multiples, which is going to be our next lesson. And having one system that works for everything is just much, much nicer in my opinion. So, ladder time, 36 and 12. Will they both divide by 2? Yes. Half of 36 is 18, half of 12 is 6. Will they both divide by 2? Yes. Half of 18 is 9, half of 6 is 3. Will they both divide by 2? No. So move on. Will they both divide by 3? Yes. 9 divided by 3 is 3. 3 divided by 3 is 1. Done. As soon as you get to 1, you know you're done. Now this time I have 4 numbers. I have 3 numbers. I can count on the left-hand side. 2 and 2 and 3. 2 times 2 times 3 is 12. And the GCF of 36 and 12 is in fact 12. 18 and 45. Will they both divide by 2? No. 45 is not even. Will they both divide by 3? Yes. 18 divided by 3 is 6, and 45 divided by 3 is 15. Will they both divide by 3? Yes. Half of 6 is, 6 divided by 3 is 2. 15 divided by 3 is 5. Once there are prime numbers on the bottom, we're done. What numbers are on the left? The 3s, the 2 3s. So 3 times 3 tells me my GCF is 9. I invite you to pause and try 12 to 14. Both of these will divide by 2. These won't, but they will divide by 3. As soon as a prime number shows up, I know I'm done. GCF of 36 and 30 is 2 times 3. That is 6. Will these divide by 2? Yes, they're both even. That'll give me 16 and 12. They're both even, so I can divide by 2 again. That gets me 8 and 6. They're both even, so I can divide by 2 again. That'll get me 4 and 3. 3 is prime, so I'm done. What's my GCF? Well, 2 times 2 times 2 is 8. Will they both divide by 2? Yes. Half of 22 is 11. Half of 44 is 22. Will they divide by 2? No. 3? No. 4? Why did I say 4? 5? No. 7? No. 11? Yes. 11 divided by 11 is 1. 22 divided by 11 is 2. Once we have prime numbers on the bottom, we know we're done. Our GCF is 2 times 11, which is 22. Now here's why I really like the ladder. It works for groups of 3 as well. Will they all divide by 2? Yes. 16 divided by 2 is 8. 36 divided by 2 is 18. 6 divided by 2 is 3. Will they all divide by 2? No. Will they all divide by 3? No. I'm done. 3 is a prime number. I do need to check if it'll divide by, but as soon as I know that all 3 won't divide by a number, I'm done. So what's my GCF here? Literally just 2. 27, 45, and 36. Will they all divide by 2? No. Only 36 would. Will they all divide by 3? Yes. 27 divided by 3 is 9. 45 divided by 3 is 15. And 36 divided by 3 is 12. Will these divide by 3? Yes. 9 divided by 3 is 3. 15 divided by 3 is 5. And 12 divided by 3 is 4. I have multiple prime numbers in my bottom list. They will not all divide by 3, so we're done. Grab my two guys off the left side. 3 times 3 tells me the GCF is 9. I invite you to pause and give 17 and 18 a shot. They will not divide by 2, they won't divide by 3, they won't divide by 5. They will all divide by 7. It gives me 4, 7, and 5. Because I was dividing by 7 and I know 4 and 5 are smaller, I'm done. GCF is just 7. And for number 18, the only thing that they will all divide by is 11. So our GCF is 11.